Welcome back. So let us begin with the next topic, which is matrices. And I think this is one of the most easiest topics, right? So without a further ado, let's get started. So let us start with the definition of a matrix. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. So can you see numbers here? They're arranged in rows and columns, right? So that is how we basically depict a matrix. Okay. The general representation of a matrix is A is equal to Aij M into N. I here represents a row, J here represents a column, right? And M into N basically represents the total number of rows and total number of columns in the matrix. Therefore, if we see this, okay, now if we take an example of an element, okay, so Aij, which I told you, this entire thing basically represents the elements of a matrix. Now let me give you an example. If I say, find the element A 2, 3. This basically refers to that you need to find the element which belongs to the second row, that means the B1, and the third column, which is this. Which element is it? Of course, it is 0. If I say find A1, 2, that basically refers to that you need to find the element which basically lies in the row 1, okay, which is this row, okay, and its second column, which is this, which is the element which is lying here, that is 3. So when I say A2, 3, this is my entire element. 2 here represents the row and 3 here represents the column. Okay, so rows, they basically run horizontally and columns, they run vertically. This is a worked example right here. 3 brothers clothing inventory, pants, shirts, bush shirts and ties, right? So there are 3 brothers, A, B, and C. And we have pants, shirts, bush shirts and ties right here. Fine. So this is a 3 by 4 matrix. That means that it has 3 rows and 4 columns, right? So the M into N basically depicts the total number of rows and total number of columns. So if I write 3 by 4 here, it basically means that my matrix has 3 rows and 4 columns. A matrix is defined as a rectangular array of elements arranged in rows and columns, treated as a single entity. You should also know the meaning of certain terms associated with matrix. So first is the element. So each individual number inside the matrix. So A11, A21, A31, A12, A22. So these are all the elements of a matrix. Row is basically a horizontal line of elements and column is a vertical line of elements. A matrix is denoted by a capital letter. It could be A, B, C, D, etc. Position Aij if I talk about. So I is the row number and J is the column number of the element, as I just explained. Now let us talk about the order of a matrix. If a matrix has m rows and n columns, it's written as m by n, right? So here order, number of rows by number of columns. If you see here, we have 3 rows. Okay, and how many columns do we have? 4 columns. That is why we write it to be 3 by 4 matrix. If you see here, it is a 2 by 2 matrix. So it has 2 rows and 2 columns. Also, it is a square matrix, right? Because it has equal number of rows and columns. So wherever you find a matrix which has equal number of rows and columns, it is termed as a square matrix. Otherwise, it is a rectangular matrix, right? Which is a rectangular array of numbers. Obviously, a square is also a rectangle, right? So if I talk about a column matrix, can you see this? It just has one column and it has 4 rows. So it is basically termed as a column matrix, right? It is a 4 by 1 matrix. So these are certain types of matrices. First is the row matrix. A matrix with only one row is termed as a row matrix, right? Can you see there is only one row and 3 columns here? So what is the order of this matrix? It is 1 by 3. right? So it is 1 by 3. Column matrix or matrix with only one column order. So can you see it is m by 1, which means that it has only one column and it has 3 rows. So it is 3 by 1. All right. Now rectangular matrix, the number of rows is not equal to the number of columns. Here you can see that it has 2 rows and 3 columns. So obviously they're not equal. Therefore it is a rectangular matrix. And a square matrix is a matrix in which the number of rows is equal to the number of columns. That is m is equal to n. So here 2 by 2 matrix because it has 2 rows and 2 columns. Let us talk about the 0 or the null matrix. So every element of this matrix is 0. Can you see all the elements are 0? The rows are 0, the columns are 0. Right? The elements in the rows and the columns are 0. So therefore it is a 0 or the null matrix. If I talk about the diagonal matrix, can you see all off diagonal elements are 0? Only the diagonal elements, this part right here. Okay? It has numbers, right? But the other non-diagonal elements, can you see they're all 0? Therefore, it is termed as a diagonal matrix. If I talk about a scalar matrix, so a diagonal matrix whose diagonal elements are all equal. So it is a scalar matrix, right? Can you see that we have basically all the non-diagonal elements to be 0 in this matrix and all the diagonal elements they're same, which is 4. So this is a scalar matrix. Now here it could be also like this. 1 0 0 0 1 0 and 0 0 1. Okay, so this is also a scalar matrix. Now if I talk about the identity matrix, a diagonal matrix whose diagonal elements are all 1. So here this is a scalar as well as an identity matrix. Okay, the diagonal elements should all be equal to 1. Rest all non-diagonal elements should be 0. So if I talk about an upper triangular matrix, so all the elements below the main diagonal are 0. Can you see the diagonal 1, 3 and 6? And all the elements below that diagonal are all 0. That is why it is referred to as the upper triangular matrix, where all the elements in the upper half of the diagonal are numbers apart from 0, but below the diagonals are all 0. If I talk about the lower triangular matrix, all elements above the main diagonal are 0, right? Can you see the elements or the numbers below the diagonal? They're all numbers apart from 0. But whereas if I talk about numbers above the main diagonal, they're all 0. Therefore, it is a lower triangular matrix. Now, if I talk about a symmetric matrix, so elements mirror across the diagonal. So, let me also talk about transpose here. Transposing of a matrix basically means that you are interchanging the rows and columns, right? So if this is the row, in my matrix, I'm going to turn it into a column, right? Let's do it, okay? So now I'm drawing a matrix B, okay? This was my matrix A. Now here, all the rows would be transformed into columns. So 1 1 0 is the row. So I'll put it as column here now. 1 1 0. 1 2 2 is the row here, right? I'm going to put it as column 1 2 2. 0 2 3 is the row here. I'm going to put it as column. Can you see that after transposing this matrix, that means interchanging the rows and columns, my matrix is the same. 1 1 0 1 2 2 0 2 3. Can you see it's mirroring? That means it is a symmetric matrix. That means A dash is equal to A. What is A dash? A dash refers to the transpose of a matrix wherein you basically change the rows into columns and the columns into rows, right? So this is a symmetric matrix. Now let us talk about the skew symmetric matrix. Aij is equal to minus Aji. That means again we are doing the transpose. Okay. And we are going to get the negative of the matrix here. Let us see how. Okay, so this was my A matrix again. And now I'm going to make my B matrix by transposing all of this. Fine. So 0, 2, minus 3. It is going to come here 0, 2, minus 3. Then minus 2, 0, 5. So minus 2, 0, 5. 3 minus 5 and 0. Now can you see that each element has gotten a negative sign. All the positive elements, they've gotten negative, and all the negative elements are positive now. That means we have got the negative of our matrix. Here you can see it was 2 here, now we have got -2. Here it was -3, now we have got 3 here, right? So also remember one more fact about skew symmetric matrix, that all the diagonal elements are always 0 in a skew symmetric matrix. So when we transpose a skew symmetric matrix, we get the negative of the matrix itself, right? So this is a skew symmetric matrix. Okay, so now let us talk about the equality of matrices. So both matrices, first of all, should be of the same order. That means that the number of rows and columns in both the matrices should be equal. Can you see here? This matrix right here is basically a 2 by 2 matrix. And this matrix right here is also a 2 by 2 matrix. So therefore, first condition is fulfilled, that the matrices should be of the same order. Second, every corresponding element must be equal. That means that Aij is equal to Bij for all ij. That means that the elements in my matrix A should be equal to the elements in my matrix B. Fine. See this example right here. Can you see 1, 2, 3? Okay, 1, 2, 3. 2, 3, 1, 2, 3, 2. So now this element does not match. Therefore, they are not equal, right? So therefore, these matrices, in order to be equal, requires two conditions. First is that the order of the matrix should be same and every corresponding element must be equal. Now, let us talk about the addition of the matrices. So matrices must be of the same order in order to be added, right? So A plus B is equal to Aij plus Bij. That means you have to add the corresponding elements of both the matrices. For example, you have to add 2 and -3 together to get -1. So 2 plus -3 is -1. 0 plus 6 is 6. -5 plus 4 is -1. 6 plus 1 is 7. Fine. If you see this example, again it has the same number of rows and columns. Therefore, the first condition is satisfied. Both of them are 3 by 3 matrices, right? So when you add the corresponding elements, you would get this, right? So this is a practice question. Let us solve it ourselves. Okay, so there's a matrix A, which is 4, 1, 2, and 3. That basically refers to 4, 1, 2, and 3. And then we have a B matrix, which is 1, 5, 0, and 2. Right now we are going to do A plus B. Okay, A plus B. So what we will get here, 4 plus 1 is 5. 1 plus 5 is 6. 2 plus 0 is 2. 3 plus 2 is 5. So we get 5, 6, 2, 5. Okay. Now, these are some properties of matrices, that it is commutative, which means that A plus B is equal to B plus A. Associative, that means A plus B. If we add A plus B first and then we add it with C, it would be equal to B plus C, and then we add it to A. Identity, that means that if we are going to add the matrix by 0 or with 0, we are going to get the matrix itself. Okay. Now let us see the subtraction of matrices. So again, the corresponding elements, matrices must be of the same order, right? So 1 minus of -1, 1 minus of -1. What do we get? 2 minus 3 minus 3. It gives us -6. 0 minus of -2 gives us 2. Right? So these are certain examples, right? In this question, if you see, it has been given that we need to find A minus 2 of B. 2 of B basically refers to that we are multiplying this 2 with the entire matrix. So 2 would be multiplied by 0, then 1, then 0, then 1, 0, 1, 0, 0, 0, and 1. Fine. So let us solve this. Let us take out minus 2b, okay? So it is going to come minus 2 into 0 is 0. 2, 0, 2, 0, 0, 0, 0, 2. Right now you have to subtract. 1 minus 0 is 1, right? 3 minus 2 is 1. So therefore you can find the whole of this matrix, right? A minus B is the same as A plus of minus B. We know this, right? Because plus minus becomes minus itself. Now subtraction is not commutative. Like we talked about addition, that it holds the commutative property to be true, but it is not in the case of subtraction. Here A minus B is not equals to B minus A. Order of matrices must match exactly before subtracting, okay? So order should be the same. Here all of these matrices are basically 3 by 3 matrices. Therefore it is easy for us to do the subtraction, or it wouldn't have been possible. Now let us talk about the scalar multiplication. So every element of the matrix is multiplied by the scalar k, right? So for example, if k is equal to 3 here, okay, and I have the matrix to be 1, 2, 0 and minus 1. Okay, and I have to multiply this entire matrix by 3. So what I'm basically going to do is I'm going to multiply k, that is my 3, with each element of the matrix. So 3 with 1, 3 with 2, 3 with 0 and 3 with minus 1. So we are going to get 3, 6, 0, minus 3. Okay, which is this. We can do similar thing here also, right? Here k is minus 2. So you're going to change the signs as well. Okay. So minus 8, 0, minus 4 and minus 10. So if you have been given k, a plus b, so you're going to basically multiply k by a first, right? And then plus and then k by b. Alright. Similar thing you can do here. k1a is equal to k2a. Fine. Now, these are certain common mistakes. Multiplying only one element instead of all the elements. Just don't multiply the first element with it. Okay? You have to multiply all the elements inside a matrix with the constant given to you. Second, confusing scalar multiplication with matrix multiplication. We are going to study the matrix multiplication next, right? So don't confuse both of them. And forgetting the sign where k is negative. So here k was negative, right? So we have to change the signs as well. Now for matrix multiplication, the compatibility condition, as we had seen in the addition and the subtraction, that the rows and columns of both the matrices should be equal. So the condition for multiplication is that the number of columns of A must be equal to the number of rows of B, right? Can you see here that this matrix A has m rows and n columns, and this matrix B here has n rows and q columns. The condition is that the columns of A must be equal to the number of rows of B. That means columns of A, so it is n here, is equal to the rows of the matrix B, right? What is going to be the order? The remaining M and Q here would be the order of the matrix so formed. Let us see how. You can see this is matrix A. Okay, what is the order? 4 into 1 or 4 by 1. This is the matrix B right here, this one, right? What is the matrix? What is the order? It is 1 by 4. Can you see the number of columns of the matrix A is equal to the number of rows of the matrix B? Therefore, they're compatible. That means we can perform the multiplication. We can find AB. Now, what is going to be the order of AB? It is going to be 4 by 4. This. Now, how are we going to multiply? Take a row of A and a column of B. Okay. Or we could basically take 3 here, fine, and multiply it by column of B. Okay. Let us simplify this. So here, 3 would be multiplied by this column first. We are going to get 12. Okay. Then we are going to multiply 3 by 2 here. We are going to get 6. Then we are going to multiply 3 by minus 1 here. We are going to get minus 3. And then we are going to multiply 3 by 0 here. We are going to get 0. Okay. Now similar thing we are going to do with 0 here. We are going to multiply each and every element of matrix T with 0. So we are going to get 0, 0, 0, 0. Then 5 4s are 20, 5 2s are 10, 5 into minus 1 is minus 5, 0. And then we are going to multiply 1 by each element. We are going to get 4, 2, minus 1 and 0. Right? So the result fills one cell of the product matrix. Repeat for every row column combination. Right? So each element, that is sum of row I of A multiplied by column J of B. So we are basically multiplying row of A with the column of J correspondingly. Right? I hope this is clear. Now these are certain important properties to remember. So if we talk about the commutative property, we saw that it holds in the case of addition, but not in the case of subtraction, and also not in the case of multiplication. Fine. Associative, it holds in the case of addition, okay, and it also holds in the case of multiplication. Distributive, if we talk about, so in multiplication we have the distributive property. That means we are going to multiply A by B first, and then we are going to put the addition sign, and then A by C. Identity element, so if we add 0 to a matrix, we are going to get the matrix itself. If I'm going to multiply A by I is your scalar matrix, okay, scalar or identity matrix, I would rather say 1 0 0 1. If I'm going to multiply any matrix by this, we are going to get the matrix itself. All right. Now zero property. If I'm going to add my matrix and the negative of that matrix, I'm going to get 0. AB can be 0 even if A is not equals to 0 and B is not equals to 0. So it can be 0. And even if one of the matrix is basically a 0 matrix or a null matrix, so again your AB can be 0. So these are certain common mistakes. Okay, first is wrong order. So writing BA when the question asks for AB. So you have to check if the question is asking BA, that means to multiply the matrix B by A or A by B. Okay. Second is avoiding incompatible matrices. Don't try to add or subtract matrices which do not have the same order. That means the number of rows and columns are not equal in both of the matrices. Third, multiplying element by element like addition instead of row and column, right? So just don't multiply elements like that, like you do addition or subtraction. Not checking that columns of A is equal to rows of B before multiplying. So please also check the compatibility of both the matrices. I have certain questions for you. You may solve them and let me know if you have any problem. These are more challenging questions, right? You can see all these questions. They are a bit harder, but I think it is going to improve, okay, your mathematical skills. You could also practice these questions, right? So yeah, that's it. Thank you. And we're going to meet in the next video. Till then, take care and bye.